All right. Hello and welcome, my lovely people. I'm glad you're here, and let's jump into the topic. And the topic is actually starting with the description of why I started to think about things in different manner, right? Why I decided that the projects I was working on are not that great, or I want to be better for the future, and I want my projects to be better for the future. And I hope this will bring you some inspiration. So let's start off with a short story about something that I would call vehicle ID. And the general thing is, I was working on a project where we were selling policies and policies for the vehicles. It was not only cars, there was some other things. That's why we used a word vehicle as a general term. And those policies obviously were relating to a specific vehicle. And I was approached and asked to fix a bug in the code. And I was going through the code, trying to figure it out. I was full debugging mode. And then I saw something that was not expected. I saw the policy referring to vehicle ID of number minus 3559. And I scratched my head trying to figure out what's happening, right? And I was going through the code. It was weird. The ID was obviously an integer, but why negative? And I've started to go through the policy table and the data in it. And actually, some policies were referring to negative vehicle IDs. So I took a look at vehicle table, and then there was not a single one that was negative. So I was confused. And then I started to take a longer, harder look at the policy table once more. And it turned out that the column named vehicle ID is not a foreign key, actually. So it tripped me up, and I've started to wonder, like, what's happening here. And I approached the guy that I would call a subject matter expert, and I asked him, like, what's going on? Do you understand what's happening? Because I don't see that data in our database, right? What's going on? And he goes, I kid you not, with a classic, that's actually a feature. You've got my attention, mate. Continue. Please describe to me what's the feature like. And they realized some time ago that the policies could actually be also sold not only for the vehicle themselves, but also for the drivers, for the specific drivers. And they decided, since they had about 7 layers in the architecture, or 7 layers where the code is coming through, they decided that that information, whether that is a vehicle or a driver, was only relevant for the first and very last layer. So they decided that they don't want to change all the layers in between. So they removed a foreign key, and they used a driver ID flipped through the zero, so in the negatives. So what I saw was actually a driver ID, but in the negatives. And that boggled my mind a bit, right? Because I didn't find it in the documentation. I didn't find it in the code because I was fixing a bug in one of those middle layers. I didn't find it anywhere, right? So I'm asking, like, how the heck am I supposed to know that, right? And why did you do that in the first place? And he said that, well, it shortened the implementation by 2 weeks. And as always, as the business wants the features as soon as possible. So they decided that is a good idea to shorten that implementation and leave this huge issue in the code that you don't understand what's going on. This is the exact moment I decided, no, I want my projects to be better than that. All right, so hello everyone once more, and this topic is onions have layers. We'll be talking mostly about domain modeling and onion architecture, and that whole concept is a cure in my head for programmers' headache, and it's actually something of a recipe that I created for my own, and maybe you'll find it interesting too. First things first, onions have layers and ogres have layers. Like if you read the title and didn't think about that quote, I've got some bad news for you because you're missing out on one of the best comedies of all time, and I absolutely love it. And if you don't, you may not like my sense of humor. I'm talking obviously about a, an animated film about a big ass green ogre, and I absolutely refuse to deal with copyrights, so that needs to be enough for you today. I hope you know what I'm referring to. And do you remember what was said next, perhaps? It was something along the lines of not everybody likes onions. Cake! Everybody loves cake. Cake have layers, so maybe our architecture should be called cake architecture? Maybe. Um, and either way, do you remember who said that? Because I do. And that was the donkey. That's the wrong picture. I don't know how it got there. Yeah, that's the donkey. Alright, you've been warned. Let's go with the topic. And let's start off with the agenda. Agenda for today is, as I mentioned, my recipe for onion syrup. And it only contains 4 ingredients. So let's cover them one by one. And first one is the functional paradigm. If we are talking about functional paradigm, we need to cover some basics like monads, functors, applicative, carrying, partial application, and all of that jazz. And yeah, let's say if you ever encounter a talk that is speaking about functional paradigm this way, I've got something for you. Just prepare and run. Because yes, we are all aware that functional programming is based on maths and is based on many theories, many difficult things, but for everyday use, we really don't need that. All we need to remember and all we need to understand is, like in mathematics, if you add 1 plus 1, it will always equal 2. There's no exceptions there. And that's what's important in functional programming. So let's approach the whole functional paradigm a little bit differently then. And let's start by stating 2 facts. And those facts are based solely on my experience, so your may vary, obviously. But fact number 1 then is, when we develop a system, we often focus on speed of creation, on doing that system as fast as possible, because we think that creating the system is the most time consuming part. And in general, time to market, a huge disclaimer here. Obviously, there are some projects where time to market is crucial. For example, anything that dealt with blockchain, Bitcoin, and all of the crypto, it was crucial for the project to be one of the firsts. So there are exceptions here. But I'm talking mostly about what I write, and what I write is usual business applications. So if we focus on the aspect of creating it fast, we usually go into the route of using what is ready, using what is tested, tried and true, and we are using design patterns and abstractions all over the place. And while there's nothing wrong with them, when you use too much of them, it becomes a hurdle. It becomes an issue, and it actually slows you down in the long run. And don't even get me started on debugging such a system. It's an absolute nightmare. I hate it. Then, fact number 2, I would say, is when we develop a system, we should focus on what is done more to the system in the long run, and that is ease of maintenance and ease of change, ease of introducing change, because our domains change. Like, take a look at COVID. Like, if there's something that changed our lives very much in the last few years, that's COVID, right? And that's what's happening to our systems. We need to be ready for the change. And when we want to be ready for the change and ease of maintenance, I think simplicity becomes the most important value in our software. That's my opinion, at least. All right. Reasons why I love functional paradigm. Reason number one is serverless. And I'm using serverless wherever I can. I love it. It actually brings us scaling like for free pretty much, because serverless solutions can scale almost indefinitely on as many hosts as you would like, however you want to approach it, right? And I enjoy that. I think it's a great way to write software. But did you ever wonder why is that? Well, because serverless applications are focused solely on what's coming in and what's coming out. There's nothing really in between that matters. And at least like 7 years ago, the first time I heard about serverless, it was really an issue that you couldn't really use a host configuration extensively. You couldn't really rely on the hosts because, well, as we mentioned with the scaling, it can scale and run on very different hosts, right? And 7 years ago, I think that was an issue. But today we write software differently. We don't want to rely on hosts. We want to containerize our things as much as we can, and we want to be as independent as we can on hosts. And that's personally why I think serverless is getting so popular, by the way. And there's also like the elephant in the room. The naming in the cloud providers is not a coincidence. Azure Functions, AWS Lambda, Google Cloud Functions, those names suggest heavily that serverless and functional is pretty much the same thing, right? And that's good. That's actually why I started to paint myself interested in functional paradigm in the first place. Alright, reason number two why I love functional paradigm is TDD. Because when you use TDD, which is a great engineering practice, what you produce is actually testable code. It's a code that doesn't get or doesn't have any states because it's hard to test, and it definitely is lacking any hard dependencies inside. All of the dependencies are abstracted and taken out so you can test that code. And I think that's beautiful. But that code also means it's a bit functional, because that's one-to-one what's happening in functional. And talking about TDD, there's one thing that I realized pretty recently. When I was actually going to one of the conferences here in Poland, and when you turn on your car, when you turn the key in the ignition, all of the controls light up for a second just so they can disappear a moment after, right? And why is that? It's because the car wants to show you, the driver, that the controls work, that the light is still there, it's working fine, and it's available to be used. So when you see those controls light up and then go back down, like turn off, you are sure your engine is fine, it's all right. And this is the exact same reason why in TDD we start off with a red test. Because, well, we're humans, right? We make mistakes, but if we see the test fails first, then we're sure it works. It's just like that little light in your car. All right, reason number 3 for functional paradigm. It's immutability. And I know, everybody talking about functional talks about immutability like it's like the holy grail of programming. And I think it kind of is. So I'm here with all of that, right? And I also think it's a way to shorten all of your debugging sessions right away. Let me show you an example what I mean. What we've got on the screen is C# code, and let's start reading it from the totally random line number 69, where we create the list of users, right? And the list of users, bear in mind two things here. So first of all of them were born in 2001, 2, and 3, so all of them are adults at this point in time. The second thing is only the first user, the user 1, has set the last name. And the last name is very creative. It's called this, but more on that later. Line 76, what we do to that list is we filter it so we get only the adult users, which should be all 3 of them, right? And then we pick the first user that actually has a last name in the first place, which will be the first user, and then we pick the last name out of that. So what we expect in line 81 is name is this. But what we do get actually is an exception, that the sequence contains no matching element. And why is that, you may ask? Let's take a look at the code once more. The only thing that I can see here which may be an issue is line 77, where isAdult is run, because perhaps we're using 40 as the adult age. Let's see. And actually in the line 66, the calculation for isAdult is using the 18 years old, so it's correct and it's fine. But unfortunately on line number 65, there's a troll there. Because somebody decided that the user that gets passed to the method by the reference will have reset last name to nothing. Which means there is no user that has a last name in the end. And I know what you're thinking, this code is the stupidest code you've ever seen, and I agree, I wrote it myself. But bear in mind one thing, if this is your production code, if you encounter this line in your production code, you probably cannot just flat out remove it. Because if this method is used in 50 places in your code, perhaps one of the features rely on that line. And without a proper slew of tests, you cannot really be certain if removing that line wouldn't break some other feature. So, unfortunately, you probably cannot remove it. And this would never happen if we would be using functional. It just wouldn't happen, that's it. Alright, reason number 4 why I love functional paradigm is what I observe in the C# language itself. It's the direction of the C# language itself. Because what I picked here, linku, records, pattern matching, and nullable in CSproj are things that I would consider strictly functional, and actually those are the things that are picked from language F# and added to C# pretty much. But those things are functional, and C# is going into the direction of allowing us to use the functional paradigm, which is great. But if you've ever tried that, unfortunately, C# allows you to do many things that make immutability quite hard. So it's not gonna be perfect, unfortunately. Let's move on to the next item on the list on the recipe, and that is the F# language itself, which for me is great because it's strongly typed, first of all. And if you're a JavaScript or a Python developer, please don't hate me very much. I've prepared a wheelbarrow for you if you want to take me out right after the talk. But I like my language to be strongly typed. I love when half of my work can be done by the compiler, not by me. I love it. The second reason is I also contemplated about using Kotlin, and I think it's an awesome language, but I don't want to learn the whole JVM's environment. I'm a C# developer, and that would be the completely new environment that I would have to learn, so I didn't want to do that. And if you think my strategy is to piss off every developer of every other language in the world, that may be my strategy, but if it is, it's immensely stupid, so let's not go there. All right, let's move on. The third reason is the F# is an actual official .NET language, and as I mentioned, I'm a C# developer. I do know .NET and I use it daily, so there's something that is easy for me. .NET works everywhere. It's no longer bound to Windows. Thank goodness. It took us quite a few years to get here, but we're here, and I'm very glad we're here. It also gives us the whole slew of NuGet packages, which I absolutely love. And I was worried at first because most of the NuGet packages are obviously written in C#. So I was worried F# plus C# would be a hard sell here, but actually F# is pretty much made to cooperate nicely with C#, so no worries there. It's fine. I tried it. It works good. And what better way to show you what I love the language other than just showing you an example. And the example will be a Mars rover. And what I want to show you, and what I want you to understand and think about Mars rover, is that this is a vehicle which obviously is very complicated to build, but in terms of its movement, it's actually quite simple, right? Because what the Mars rover can do is pretty much go forward or backwards or rotate. So it doesn't go sideways, it rotates. At least that's how I see it. Perhaps it's not accurate actually, but never mind. This is the domain we're dealing with. So it can either go forward, backward, or rotate and then go forward, backward, right? All right. So how does it look like in F#? Well, what we have in here is simple position on map, which is simple coordinates. We've got a direction, which you can think about as the enum in C# for the time being. In F#, it's actually called a discriminated union. More on that in a moment. Line 8 is actually specifying the type rover. What else do we have here? We've got the command move, as I mentioned. We can go forward or backward, or we can rotate left or right. Then we also have the type command, which consists of either move, which has a command move underneath, or rotate, which has command rotate underneath. And a little bit below in the line 30, we can actually specify a type for a function. And how do you read that? The type is rotate rover, which the function accepts command rotate. It also accepts the rover, and then it produces a new rover, which is already rotated. That's how the functional world looks like and works like. And how do we implement such a function? Well, this is it. And I want you to focus on the line 49 when we have the pattern matching. And we are matching on two things. One is the current rover direction, and the other one is that rotate command left or right. So looking at line 50, when you are facing north and you are rotating left, you will be then facing west. So you return a new rover based on that previous one with a new direction west. And this sort of pattern matching is used so extensively in F#. It's really a default, I would call it, default way of programming. And I believe and I think this is the definition of readability. It's so simple. It's so beautiful in this regard. I absolutely love it. All right, moving on. So we had F sharp covered. Now we're gonna talk about domain modeling. And what do I mean by domain modeling in the first place? What I mean is the part of the whole DDD. It's actually one of the first parts when you create a model in your code based on the domain that you are working with, right? So what we want to achieve, or what we don't want to achieve, is the code that you see on the screen. And even if it's a absolutely beautiful background actually here, I love it, I don't want to read that code ever. Because it's complicated, it's convoluted. The names are a bit suggestive, but not so much. So yeah, I don't want to read that code, and I don't want to work with it. What I want to work with it, or what I want to work with, is the code that sees eye to eye with the domain. So whatever language is used in the domain should also be used in the code, right? So vehicles, policies, vehicles not cars, right? All those things make sense to be used in the code. Like, why do you want to play a human translator all the time, right? Use the language that is used in the domain, and that is domain modeling for me. Moreover, if we are talking domain modeling and F sharp, actually, there's no way in hell I will not mention Scott Vlashin. And especially his book called Domain Modeling Made Functional. And guys, Scott Vlashin for F sharp developers is an absolute treasure. Like, we love the guy, we respect him, and he's really, really good at explaining things. Very much recommended. He's an author, he's a speaker, he's an awesome guy, and if I ever will have a chance to meet him, I want to buy him a beer. Seriously, he's awesome. And as I mentioned, he's an author of not only domain modeling made functional, but also of F sharp for fun and profit, which is a website which is pretty much the best tutorial I have ever read, and I've read quite a few of those. I mean, if you're at least a little bit interested in F sharp, go take a look. You won't regret it. And domain modeling made functional is not only a book, it's also a talk on YouTube. Like, you can find it on YouTube. And me personally, I prefer that way of learning rather than reading a book, usually. So yeah, just want to mention that up. And what I want to talk about, once again referring to domain modeling, is hybrid vehicle. What do I mean by a hybrid vehicle? Like, think for a moment about cars that are popular now. I'm talking about hybrids. And hybrids in very simple terms. I'm dumbing it down a little bit to describe my domain, right? Hybrids are pretty much just jamming into one car the electric engine and the gasoline engine. So that car has actually two engines underneath, and it's either switching between them or using them at the same time. It doesn't really matter for us at this very moment, but this is what I would refer to and what I would call a hybrid. A hybrid, right? So how do we model that in F sharp? How do we show that? Let's take a look. So we have now 4 lines of helper types. Don't worry too much about those. And what we have in here is line number 8 and 12. We've got gasoline engine and electric engine. Those have a little bit different parameters, and that's completely fine. But the magic happens in the next step. And the next step looks like this. This is once again what I promised we will come back to. This is a discriminated union type, which is called engine or hybrid. An engine or hybrid is an enum with a type underneath. So when we have the gasoline label, the underneath type is gasoline engine. When we have electric label, we've got electric engine underneath. But when we have the hybrid label, we're actually using gasoline engine and electric engine. So you cannot try and push in 2 electric engines in one car here. You have those two. And you also cannot create a hybrid with only gasoline engine. You need both of those. And this is one-to-one what I described in my domain. So the code is speaking the truth about the domain. All right. I think those very simple types within functional programming are actually a great fit for domain modeling. So yeah, maybe consider that rather than objects. All right. Moving on, we've come to the very last and most important point, which is onion architecture. And what's so good about it? Why isn't this a cake? And that's probably based on the fact that somebody realized that layers in onions are circular, and that actually shows quite nicely the relationship between them. This is how the onion architecture looks like in general, right? In the very middle, you've got your domain model. It lives there, it's fine. Right outside, you've got so-called application layer, which is dealing with anything business logic wise. So anything according to what you want to do with the domain objects will live in the application layer. And then on the outside of that, you've got some layers that are helping, but not really important to the domain logic itself. So we've got persistence, presentation, infrastructure, and so on. And I want you to take a look at those arrows. They always point inward. And this is the most important thing about onion architecture, that relationship between the layers. And how I want you to think about it is like a thin client, like that presentation layer is a thin client for the application. Once more, what do I mean? Thin client, think about for a moment a web browser of yours, right? And when the web browser acts like a thin client, it always goes to the endpoint for any data whatsoever, right? So if it wants to display a list of users, it goes to the backend, to the endpoint for the list of users. If it wants to change something in the user, it doesn't only change in the web browser itself. At the very end, it sends the data once again to the backend, right? So this is how I want you to think about those outer layers in onion architecture. Those are thin clients. And talking about the architecture once more, I think let's take a look at the example. And example will talk about electronics shop. And I know if you're watching this, you probably have your favorite electronics shop. And no judgment here. I've got my own favorite one. So no judgment whatsoever. And we are going to talk about electronics shop, and mostly we'll focus on the receipt in that shop, right? So where do we place receipt in this whole architecture, and how do we approach it? Well, receipt is a domain object in general, right? Excuse me. So it lives in the domain. Whatever we want to do with that receipt, for example, issuing a receipt, lies a little bit outside in the application layer. Because issuing a receipt is an actual business logic. Even if the business logic is simple and is just matching the products that you bought and the user that bought it, this is still a business logic. So it lives in the application. And it wouldn't be complete without storing that receipt somewhere in the system. So what we want to do is save that receipt. And this obviously will be done by a persistence layer. So saving the receipt in the database goes into the persistence layer. But the most important thing to ensure those beautiful clean dependencies is that the interface for saving that receipt lives in application layer. And this is something that I was getting wrong for I don't know how many years now. But I thought that the interface for saving into the database is a part of the persistence layers, so it should live in the persistence layer. And not at all, actually. It should live in the application layer because the application layer, while issuing a receipt, knows it needs to be saved. It doesn't care how, it doesn't care about the database. It knows it needs to be triggered, that save action, so the interface lives in the application layer. And this is brilliant. Obviously, you can use it not only in the Onion architecture, but this is where I've actually learned to understand it. And I encourage you to try it out. So, one takeaway here is that the database can actually have a different model of the receipt, and that is completely fine. So, saving that receipt can have its own model, but that own model lives in the persistence layer, never goes out of the persistence layer. It's part of that layer. And we don't see it, don't talk about it. It's there, it's good. All right, I've got two more pointers, two more tips to think about Onion architecture that changed the way I looked at it. So one is TDD. As I mentioned, I think it's a great practice, great engineering practice. But if we want to write our code in TDD, what we obviously focus on is the business logic. And since the whole business logic is closed in the application layer, our TDD efforts can be focused or can be done solely in the application and domain layers. Those two layers use TDD. The rest of it may use different sort of testing, right? Actual integration testing, right? But it doesn't make much sense to use TDD to test out mocks of the database, right? It's not useful at all. So whatever is happening within application and within business logic can be written with TDD, and that's fine. That actually encloses us a bit so we don't go crazy with the amount of unit tests. The other thing is, I would even say even a bit more important, and this is something that I was approached on one of the conferences, and one of the attendees just asked me, okay, fine, but if we are enclosing everything in an application, even the interface to save to the database, we still need to register in our dependency injection container not only the interface, but also the implementation. So we need to reference both application and persistence. And he wanted to do that in the application, but that would screw up the whole setup with references, right? And we don't do that here. What we do instead is create an even more outer layer, which in that example would be an HTTP endpoint, which uses the application layer, but also gets the reference to the persistence layer only to register in the dependency injection. That's it. All right, at the very end, I've got a question for you. How do you design your architecture? Where do you start? Do you start like I was doing for the past few years with the model of the database, which is usually relational, and then you play human compiler all the time while talking to the business? Or do you start with the actual domain language. Alright, that was my recipe for onion syrup. Thank you very much for listening to me. And if you want to stay in touch, I recommend LinkedIn. I'm active there, and it's probably easiest to find me there. And thank you very much for your attention. And as always, we can do better as a pack. Bye.